All right, practice exam 2, problem number 7. All right, so we're going to use Rolle's theorem to prove that x cubed plus x minus 1 equals 0 has at most one real root. All right, so in order to prove that, what we're going to do is we're going to assume that, let's say there are more than one. Then you try to get into trouble. So try to get a contradiction by assuming that there are more than one roots. All right. So let's do that. So this is proof by contradiction. All right. So let's. I'm gonna let function f of x is equal to x cubed plus x minus 1, right? So we know that f is, right, of course, continuous everywhere, and also differentiable, because it's just a polynomial function. So differentiable everywhere, so on all real numbers, right? Since f is a polynomial function, right? So we have that. All right, so let's make this assumption. Let's assume, for the sake of argument, right, there exists two distinct roots. Roots. So x1 and x2. Let's assume that x1 is smaller than x2, right? All right. So if there are two separate roots, then but these are roots. So if you plug in x1 into the function, it should give you 0. And also, if you plug in x2 into this function, you should get 0 also, right? So this is one of the hypotheses of Rolle's theorem, right? Rolle's theorem, f has to be continuous and differentiable, and f of x1 and f of x2 gives you the same value. All right, by Rolle's theorem, we know that there exists at least one number c in between x1 and x2, such that derivative of this function at c is exactly equal to 0, right? But there's a problem with that, because look at the derivative of this function. So however, or but, if you take the derivative of this function, you will get the 3x squared plus 1, right? This guy is actually at least 1, because x squared is non-negative. You're adding 1s. So this guy is never 0. So this guy is never 0. I'll just say this is never 0, right? Which is a contradiction, because according to Rolle's theorem, you have to be able to find such c that f prime is equal to 0, but we know that that can never happen. So which is a contradiction, right? So what was wrong? What was wrong was that we assume that there are two roots. Then we get in trouble. So there cannot be more than one root, right? So hence, right, there is at most one real root, right? Because otherwise we're going to get in trouble again. All right, that's it. I hope that this was clear.